Hi, this is Arnab, Assistant Professor, Department of AI&DS, working in KIT, Kalangar Karnataka Institute of Technology. Today I am going to take the subject Design and Analysis of Algorithm. Topic is Backtracking. In Backtracking, the sum of subset problems. So, sum of subset problem. What is meant by sum of subset problem? Here, let S is equal to S1, S2 up to S power n be a set of n positive integers is a non-negative integers. Then we have to find a subset whose sum is equal to given positive integer d. They given the positive integer d. Here we have to find the whose sum is equal to a given positive integer d. So it always convenient to sort the sets element in ascending order. First we have to sort the subset in ascending order. Let us first write a general algorithm for sum of subset problem. So starts with an empty set. Second step, add to the subset the next element from the list. Third step, if the subset is having some d, if equal to some d, then stop with the subset as solutions. If the subset is not feasible, or if we have reached the end of the set, then the backtrack through the subset until we find the most suitable value. If the subset is feasible, then repeat the step 2 here. If we have visited all the elements without finding a suitable subset, and if there is no backtracking is possible, then stop without solutions. The problem can be understood with some example. So first starts consider the example. There are 5 distinct numbers 1, 2, 5, 6, 8. Find the combinations of these numbers such that the number is 9 equal to 9. So use the backtracking model to arrive at a solutions. Initially the subset equal to empty set. First I take the value 1. Now add the next element. 1 plus 2 is equal to 3. 3 is less than our positive integer d, which the subset is equal to the 9. So 3 is less than 9. So move to the next element. Then again add the another elements 1 to 5. So 1 to 5 means 8. 8 is less than 9 only. So add the next element. Then 1 to 5 6. Okay. Then 1 to 5 6 means 14. So automatically sum is exceeds the given constraints, hence backtrack the problem. So 1 to 5 8. 1 to 5 8 means 16. Sum is exit. So given constraint, hence the backtrack the problem. So we take the possible solutions 1 to 6. So 9 equal to 9. So the solution is found here. We have to draw the state space tree for the given tree. Starts with 0. With 1, without 1. With 1 means we have to add the corresponding 1. Without 1 means we do not add the 1 here. So with 1 means I am going to add the 1. So 0 plus 1, 1. With 2 means we have to add 2 value. 2 plus 1 is equal to 3. Without 2 we are going to without adding the 2 value. Then with 5 without 5. Then with 6 without 6. Suppose if some positive integer is exit means we are going to drop the elements or prune it. Okay. Here we can find the solutions with 1, with 2. 3 plus 6 9. We can find the solution here. Without 1 here again we are without 2. We get the value 2. So without 1 with 2 here. So is a state space tree, is a number of possible solutions here. Algorithm for the sum of subset problem. Here the algorithm is mainly for index value. We are passing the sum index remaining sum values. Next, W is nothing but set containing n elements, sum equal to index of weight. Okay, the remaining sum is equal to W of j here. W of j is sorted in not decreasing order. W of j is nothing but is a sum of subset problems. So here W of that subset should be less than equal to D. D is the positive integers here. Suppose if sum plus W of index equal to D means we are find our possible solution is 9. We are adding the subsets. We get the solution means we have to find the print the solutions. Otherwise we are moved to the next step. Search for the next elements which can be make sum is less than equal to D. So the process is repeated until our designated is reached. Consider another example. Let W equal to 5, 7, 10, 12, 15, 18, 20. So our positive integer is m equal to 3, 35. So find all the possible subset of W whose sum is equal to this m. First I initially take the value m 5. Okay. Then add to the next element. Second element is 7. So 5 plus 7 is equal to 12. 12 is less than 35. We can add the next element 22. 22 means we are adding the value 10. So 22 is less than 35. We can add the next element. Again 15. 15 means it will exit the solutions. So here 34. Okay, 34 means 34 is less than added. 15 means automatically it will exit the solutions. So we can prune that corresponding element. We can move to the another element. So again adding the 18. So 52 is greater than 35. So we are going to prune that value. Again adding the 20. 54 is greater than 35. We are going to prune that value. So prune the value 20. Again 12. Again we are adding the use the backtracking method. We are adding the value 15. 37 is greater than 35. Automatically exits. So we are going to prune the value. Use the concept of backtrack. Again using the backtrack concept, we are adding the 18. So 40 is greater than 35. Again we are using the concept of backtrack value. Again 5, 7, 10 and 20. 42 is greater than 35. We are using the backtrack concept only because we have not reached the corresponding solution. So 5, 7, 12. 24 is less than 35. So less than only. We are adding another value. So 5, 7, 12, 15. So here the 39 is greater than 35. Exit the value. Again adding the 18. 42 is greater than 35. Again adding the 20. 44 is greater than 35. So again we can use the backtracking method. We can find some alternate path. So 5, 10, 20, 35 equal to 35. We can find the solution. So 5, 12, 18, 35 equal to 35. We find the solutions. 15, 20, 35 equal to 35. We can find the solutions. So first we have to choose the positive integer. First we can choose the possible values to reach the 35. So these are the state space tree. Starts with 0, with 5, without 5. Again with 7, without 7. Then again with 10, without 10. With 12, without 12. So while adding the solutions here, we can 5 with 5, without 7. Again with 10, with 20. We can get the solutions here. This is one type of solutions. Again we can add without 5, without 7, without 10, without 10, without 12, without 18, with 20. We can find the solution. So this is the state space tree. Thank you.